Assalamu alaikum, guys. So in today's lecture, we are going to do pressure. Okay, so let's start. So the definition of pressure is basically the perpendicular force acting on an unit area. Okay, so this is the definition of pressure. Okay, and its symbol of is P, and its formula is force upon area or weight upon area. Okay, so basically means that F upon A or or W upon A. Okay, where weight is W and it is A. Okay, A in what? A in meter square, okay? And weight in Newton. So basically it means that N slash M square, okay? So it will be like this, okay? So its SI unit is Pascal, okay? So its SI unit is Pascal, okay? So we are done with the basics of pressure. That what's the definition of pressure? It's the perpendicular force acting on an our unit area. So basically it means that, for example, here's a object, okay? Wait, let's check. Uh, let's suppose here is a box. Okay, wait, I think this. Take let's take a piece of land. Okay, so this piece of land is approximately 100 centimeter. Okay, so when on this 1 centimeter, when a force of 10 Newton is applied, so it means the 10 Newton force is applied on 1 centimeter. Okay, so this is the pressure on it. So 10 Newton force is the pressure on this 1 centimeter. So and it's acting perpendicularly. Okay, it's acting perpendicular. So then it will be called as force. So it's sorry, it will be called as pressure. So pressure is equal to force upon area, or pressure is equal to weight upon area. If weight and force both have the same unit, which is Newton. Hence, we can either write force or either write weight. Okay. So these are the basics of pressure, and this is the main things which you guys have to note down and remember it thoroughly. Okay. So now let's do a question. So in this question, this area is given, okay? This area is given, which has a length of 10, okay? Length is equal to 10. And the breadth is equal to 20, okay? And the force applied is 30 Newton, okay? So this is the data given in this question, okay? So basically, we have to find in this question, we have to find the pressure applied on this area. So what's the formula of pressure? Pressure is P is equal to F upon A, right? So P is equal to F upon A. So in this, we know what is F, right? We know it's 30, but we don't know the area. So for finding the area of this rectangle, what do you have to do? Area of rectangle is equal to length into breadth, right? So the length is 10 and the breadth is 20, right? So we have to multiply and the answer will be, it will be, wait, 200. Okay. So the area is 200 meter. Okay. So by this, so it's 200 centimeter. Okay. So it's 200 centimeter. So then, because here the units are centimeter. Okay. Let me write. Okay. So it's 200 centimeter, right? So first you have to convert centimeter to meter. So for it means that 100 centimeter is equal to 1 meter. Okay. 100 centimeter is equal to 1 meter. So for 200 centimeter, it will be x. So then we will cross multiply it and it will be 100 x is equal to 200 centimeter, and then x will be 200 upon 100 and 0 0 cancel and x will be 2. Okay. So it means that 2 meters square is the area. Okay. So P will be 30 divided by 2, 2 ones are and 2 15s are. So the pressure or the slide will be 15 pascals. Okay. So as it is the unit pascals. Okay. So 15 pascals of force is applied on this 200 centimeter area or 2 meter area. Okay. So now let's do another question. Okay. Exercise number 2. Okay. So basically in this, a weight is given. Okay. And the area of one step is given. So we have to find the pressure applied in this area. Okay. So basically what you have to do, the weight is given. Okay. As P is equal to W upon A, right? So P is equal to W is 50 Newton, right? Upon A, right? A is unknown, A is known, but we have to change it into centimeter, right? So for this, what you have to do, we have to convert this 25 centimeter square into meters. So for this, we have to divide it by 100, 25 divided by 100, and it will be 0.25 meter. Okay, so let's put the values in the formula. So 50 upon 0.25, and the answer is, wait, let me see it in the calculator. So the answer is P is equal to 200 pascals. Okay. So we are done with the two examples. Now we have done the pressure. Now we will do pressure in liquids. Okay. So these are the two topics which we will cover in our today's lecture. Okay. So basically the pressure exerted by the liquid is calculated by the following relation, which is P is equal to rho. Okay. So wait, P is equal to rho G H. Okay, where this rho is the pressure, is where rho is the density. Okay, so let's start with the P. Okay, P is the pressure. Okay, pressure of the liquid. Okay, and rho is the density of liquid, P of liquid, while the G is the gravitational field. Okay, field strength, which is 9.8, or sometimes it's 10. Okay, Newton per kg. And the H is the depth of the liquid. Okay, is the depth of the liquid. Okay, so basically it's depth, because it's from the surface of the liquid. Okay, from the surface of the liquid. So this is the relation, that how do we calculate the pressure in liquids. Okay, so now we are done with that, how the pressure is calculated in liquid. So now let's do an example. Okay, so in this example, height is given. Okay, of how much is 150 meter. Okay, the height is 150 meter. Okay, and with it, the density, or the rho, is also given, which is 1000 kg per meter square. Okay, and as we know, the gravitational influence, the field strength is 9.8 Newton per kg, right? So we have been provided with this, and with it, we have been provided with the height, or you may also say depth. So let's put the values in the formula, and in the formula let's shoot, which is P is equal to rho GH, right? So rho is 1000 times G is 9.8 as usual, and the height is 150. Okay. So after calculating these values, we'll find an answer which is 147,000 and 0. Okay, pascals. So this is PB, and but we don't have to leave it in this form. We have to first make it in the standard form, which will be 1.47. 1, 2, 3, 4, 5, 6 times 10 to the power of 6. Okay, pascals. So this is in the standard form, and we are done with this first exercise. Now let's go on to exercise number 2. So now in this second exercise, or the question which I have taken from the past paper. Okay, In this, there is a question which in which the height is given, okay, which is 200 meter, okay, and the rho is not given, okay, means the density of the liquid is not given, and the gravitational potential field is given, and the pressure is also given. So in this, let's put these values in the formula. So which is P is equal to rho GS, right? So P, which is 1.83 times 10 to the power of 5, which is equal to rho is not given, G is 9.8 times times 200, okay. So let's solve it. So first we have to isolate rho. Okay. So for that, it will be 1.83 times 10 to the power of 5 upon 9.8 times 200. So in this, what did we do? That we have taken 1.8 to this side. Okay. Basically. So let's check in the calculator. Okay, wait. It's 93.36. Okay. Kg per meter cube. So this is the rho of the liquid. This is how we find the rho when the rho is unknown. Okay. So now let's go on exercise 3. Okay. Number. uh, So let's solve it. And this one is a little bit tricky one. Okay. So wait, let me draw. Mm, Yes. Okay. So let's suppose here is a object. Okay. This is full filled. Okay. And this object here is a dot. Okay. So the distance. Okay. So the distance of the dot from the ground is 200 meter, and distance from top to the ground is 1000 meter. Okay. So basically in this, we have been asked that we have to calculate the pressure at this point. Okay. Let's name the point A. Okay. So in this, rho is also given, which is 1000 kg. Okay. So how do you have to find the pressure? So as the values are given, but first, what do you have to do? First, we have to first we have to actually subtract 200 from 1000. Okay, why? Because the pressure is applied perpendicularly, right? So the area which is covered in the perpendicular way, it's 1000. Okay, so it's not 1000, it's 8000 minus 200, which is 800. Okay, so in this, let's put the values in the formula. So when we put the value, which is P is equal to mm, rho is 1000, sorry, multiply by 800, multiply by 200. Okay, not 200, sorry, not 200, multiply by 9.8. So when we solve it, the answer is 784,000. Let's to put it in the form. So it will be 7.84 times 10.6 pascals. Okay, so this is the answer for this second equation. Now let's, sorry, not second, but the third one. Okay, now let's do another question. Okay, let's suppose, wait, let me draw it. So let's suppose, okay, wait, let me draw a question. So in this question, there is this example, okay, which is number 4. Okay, so in this example, the water is filled till this height. Okay, this is the till, and the height of the box is 400. Okay, and the total height of this container is 1200, and the air space above the water is 500. Okay, so in this we have to calculate the pressure. So for it we have to calculate this area. Okay, so this area will be 1200 minus 500 minus 400. Okay, and that will be 300. right? So you have to calculate this 300 area, that how much pressure does it exert on this box. So for this, we know that what is the what do you say? What is the row? The row is also provided, which is 1200, okay? And this is the 300 height, okay, or the depth, and the rotational speed is 9.8, okay? So let's put the values in the equation, which is p is equal to rho, which is 1200, okay, times 9.8 times 300. So the answer is 3528000, and we have to convert it into the standard form. And for that, pascals, and 1, 2, 3, 4, 5, 6. So the answer will be 3.5 to 8 times 10, or 3.53. Let's check it. 3.53 times 10 to the power of 6 pascals. Okay. So this is the pressure on the box. How we'll calculate the pressure on the box. So now let's do the last question of this lecture. Okay. Okay. So let's do the last equation. So basically, in this exercise, we have to find out that either it will be in the either the pressure will be the greatest in A, B, or C. So the answer will be C, because in this the height is the greatest. Okay. So basically, the more the height, the more the pressure in the current. In B, the height is the less, and then C is the greatest. So basically, it will be like this. Okay. Pressure will be like this. In A. So this is how the pressure will be in this region, and this is the possible question, which is frequently asked. Okay, so that's it for guys. For today, guys, I hope you are fine and doing well, and we'll see you in the next lecture. And we'll soon upload the second part of this chapter too. Okay, inshallah. So do like, share, and subscribe this channel, and do also comment. Okay, okay, Allah Hafiz.